Hello folks, at the request of a couple of different people, I am making a new video because the old video I have is me standing in front of the classroom and I've been told that you can't see that very good. And I needed to hear things like that. So if you have other suggestions, please throw them my way. Even if it doesn't help me this year, it might help me next year. Second thing I was told is from a teacher who's actually been watching some of my videos is to try and make them short. So sorry about this 30-second intro, but I've filled in a lot of this stuff. So if you're somebody who likes to write from a blank form, like print off the blanks, you're probably going to want to pause and just copy this stuff in. For one, to convert from degrees to radians, we've already done this. There's a lot of prior knowledge here to start. To convert from degrees to radians, we just write the degrees over 1 and times it by pi over 180 and reduce it, right? So I did that over and over and over here just to show you how this is why we got to convert, because there's a lot of things with this unit circle here that we're going to have to be able to use. Alright, so in this problem, I would just put pi over 180, reduce the zeros, divide both of those by 3, get 5 pi over 6. And then I went to my table, and I went to 150 degrees, my unit circle, excuse me, and I just labeled that as 5 pi over 6. These point values we knew from section 10.5. We didn't really use them. We only used the 0, the 90, 180, 270, and 360. But the rest of these values did come from that. I'm going to talk more about that in a minute. I put pi over 180 here. I reduced it by 9 in each of these and then reduced those by 5 to get pi over 4. Here I just knew 45 went into both of those. Here they just cancel each other out. And here I cancel out the zeros divided by 6 to get 4 pi over 3. And then again I went to 240 and labeled 4 pi over 3. I went to 180 and labeled it pi. I went to, well, negative 135 is going to be the same as positive 135, which is 3 pi over 4, or negative 3 pi over 4 would get me here, right? Going clockwise, excuse me. And then so on. So we got those. The rest of these values, you can see here that I have maybe circled. These are in radians, okay? To find those, I just took each one of the degree measures, times it by pi over 180, and just reduced it. Okay, these are not things you have to memorize this year, but next year you will have to use all this, and you probably actually have to memorize all this, whether you're in pre-calc or for sure in AP Calc you will. I remember going to class when I was in high school taking AP Calc, and my teacher was at the door with flashcards for the unit circle, and I had to know what was what. So, a couple of ways to kind of hopefully help you memorize this thing. Not that you have to this year, because obviously anything I'm going to give you, you're going to have this unit circle to look at because it's online. And again, this is called the unit circle. It's something you could look up online and print your own off if you want, or just copy them in on mine. The ones over 6 are closer to the x-axis. Look, pi over 6, 5 pi over 6, they're closer to the x-axis than they are to the y. The 7 pi over 6 is closer. The 11 pi over 6. Really, this is going by pi over 6. 2 pi over 6 reduces that. 3 pi over 6 reduces that. 4 pi over 6 reduces that. 5 pi over 6 and 6 pi over 6, and so on all the way around it. But the ones that reduce to the over 6s are closest to the x-axis. The ones that reduce to the over 3s, you can see, are closer to the y-axis than they are the x. This is closer to the y. This is close to the y. So just remembering over 3 goes close to the y. Over 6 goes close there. The pi over 4s are right in the middle of the whole thing, right? They're the middle values, the ones that end in 5 degrees, okay? All the values are less than 1, okay? Above the x quadrant. So this is all goes up to 1 pi, right? Everything else is greater than 1, right? 3 pi over 2 is 1.5 pi, 1.6 repeating pi, and so on, right? Okay? All the radians from here to here are between 1 pi and 2 pi, so they're over 1. These are all under 1. Okay, and then the other thing that I help in terms of the points themselves, square root of 2 over 2 is always on the 4s, okay, on the divided by 4s, excuse me, and then it's just a matter of remembering positive and negative intervals. When you look at these points, look, this point is further over than it is up, and the square root of 3 over 2 is like 0.85 or something like that. That's always greater than 0.5, right? So the further over it is, then the bigger number better be x, because I went further in the x direction than I did the y. This point is further in the y direction than it is the x, so the y value is square root of 3 over 2. So it's always those values. You can look in every one of those boxes at square root of 3 over 2 and 1/2. In terms of determining which one goes where, it's whichever one is further out, that has to be the x is greater, If it's further down or up, then the y value has to be the bigger one. Okay, just kind of different ways to think about it. All right, how are we going to apply this? I want you to literally tell me what the exact values are for cosine and sine. And I would have made this a candy question and seen if anybody could tell me, because we've done this in 10.5. We said the cosine value of 90 degrees is 0 because the x value at 90 degrees is the cosine. So that might be helpful, is that cosine is the x value and sine is the y value. So really, all I got to do for these points is go to that value on the chart, on the unit circle, and find whether it's cosine or sine of x or y. So this is asking for the x value at 7 pi over 6, or in that case 7 pi over 6, which is 210 degrees. Now it doesn't matter which way I think about it, I'm just looking for the x value here, and the x value is, well, x comma y is there. It's just negative square root of 3 over 2. It really is that easy. The sine of 5 pi over 4, go find, excuse me, 5 pi over 4. There it is right there. It wants the y value because it's sine, right? So y at 5 pi over 4 is negative square root of 2, excuse me, over 2, right? Let me do one negative one here. Negative pi over 3 is the same as positive over 3, but in the opposite direction. So look, positive pi over 3 gets me there. So I had to go 3 dots in. So negative pi over 3, I have to go 3 dots in, gets me there. And it should always have a denominator that's the same, right? Negative pi over 3 is the same distance as pi over 3, but in the opposite direction. So negative pi over 3 gets me there, and that cosine value is 1/2. Right? Negative 3 pi over 2. Okay, so 3 pi over 2 is all the way to there. So 1, 2, 3 quadrants. So I have to go 1, 2, 3 quadrants the other way for negative. Negative is just the opposite direction, the same distance. And so I get to here, and I need the sine value, which is the y value, and so it's 1. Maybe pause the video a second and try 5 through 8. Okay, pause the video a second, just try it, identify them on here, write it in. Pause it, go. Sine of pi is the y value at pi, which is 0. Cosine is of negative 3 pi over 4. Here is 3 pi over 4. So negative 3 pi over 4 from here would be to there. It has the same denominator, good. And I need the x value, so negative square root of 2 over 2. Sine of 5 pi over 3 is right there. The y value is negative square root of 3 over 2. Because again, sine is y, cosine is x. So I got to find the x here at negative 11 pi over 6. Here's 11 pi over 6. So negative 11 pi over 6 is just that, right? So instead of going all the way this way, I'd go all the way that way to there. And again, the cosine value of the x value is square root of 3 over 2. So again, it is just literally identifying the x and y values on this unit circle. Cosine is the x value, sine is the y value. And if you really wanted to know, tangent is y over x. Okay? But I'm not going to do that to you in this section. Okay? All right, let's move on. Next page here, I've got finding the length of an arc. Okay? An arc length can be found by taking the portion of the circle and timesing it by 2 pi r. Okay? And then I have like another equivalent part here, which is theta over 360, because that's the part of the circle, times 2 pi r. And then I tried to rewrite it again because in radians 360 is 2 pi. If I went 360 pi over 180 and reduce it, I would get 2 pi. And then the 2 pi's will cancel themselves out, and I just get pi times r, excuse me, theta times r. So really what this means is just take the radius times the radians, or the radian measure if you want. Right? Radius times the radians. Okay, cool. So look, here's the radius, 6 inches. Here's the radians, 7 pi over 6. So literally to find this area, I would just take the radius times the radians. So I would go 6, I'm going to put that over 1, times 7 pi over 6. And you could go 42 pi over 6, or you could reduce those 6's and just get 7 pi either way, right? 42 over 6 would be 7 anyway. Okay, and then do I need to do that? No, because I could just go on my calculator, 6 times 7 pi divided by 6. I could literally plug it in just like I see it, and I would get about 22 inches. Okay? So take a minute, press pause, try this problem. It's giving you the radius, it's giving you 2 separate radians, and it wants you to find the area for each. Okay, press pause, try it out. Remember, it's just radius times radians. Go. So this again is 3 times for S, 5 pi over 6. So again, what I can do in my calculator, okay, you can use yours on your phone. It's going to give you the same thing. It's just 3 times 5. You know what? Let's do this on the phone calculator, okay? Because I want you to be able to see where pi is, etc. Okay. All right. Hold on a second here. So we're going to go 3 times 5 pi over 6. So 3 times 5. Let's find pi. Oh, it's in the right here above the divide sign. It looks, you got to go second, and then you do that, and then divided by 3 equals. Gives me the answer. Oh, I should have divided by 6. I'm sorry. Can I do that again? Yep. Hey, this is good because this shows us a bunch of stuff that we can do here. Let's put 5 pi over 6 because look, that's what it said, right? Okay, so enter 7.85, and in this case it's inches squared because we are finding area of circles. Next one is going to be 3 times 2 pi over 3, which I'm just going to tell you those 3's would cancel 2 pi, but I could plug 3 times 2 times pi divided by 3 and it'll spit out 6.28 inches squared. Okay, simple as that. Okay, all right. Then we get to the last part of this, which is about area of a sector. A sector is a region bounded by 2 radii and an arc of a circle. Okay, what does that mean? Okay, so we got to take the fraction of a circle divided by 360 times the area of a circle. Do you remember what area of a circle is? Yep, pi r squared. And what fraction of a circle is just whatever the degrees are divided by 360. But not everything's going to be given in degrees. Like for instance, we're going to solve this using these 2 problems up here. This is not given in degrees. So I've put here, and maybe you pause this to write this in your notes if you're doing this, that there are 2 steps. The first step is to change it from radians to degrees. The second step is to just plug in the degrees and the radius into, and maybe I should circle this because this is kind of a big deal here, into that formula. Okay, so for S, first things first, I've got 7 pi over 6. Okay, I'm going to have to change 7 pi over 6 to degrees. Okay, so 7 pi over 6 to degrees. I'm going to do that up here. 7 pi over 6 times 180 over pi. The pi's cancel. 6 goes into there once. 6 goes in there 30 times, so that's 210 degrees. While I'm at it, I'm going to do that for these problems too, just to help you out here. 5 pi over 6 equals, you know what, I don't need to do all that. Just go look. 5 pi over 6 is 150 degrees. I don't need you to go reduce that. You can just go look at the table. It's 150 degrees. The unit circle, I keep saying that, I shouldn't. 2 pi over 3 equals, well, let's go find 2 pi over 3. 2 pi over 3 right there. Cool. 120 degrees on my unit circle. Okay, alright, so when I go to fill this in, I change it from radius to degrees. Again, I can use the formula, or I could just go look at the unit circle. Right? So I've got 210 degrees divided by 360. Again, I'm plugging it into the formula, times pi times the radius, which in this case is 6 inches, squared. Okay? You could plug that in, just like that, into your calculator. Let's do it. 210 divided by 360 times second for pi times 6 squared equals 65.97. And that's what we're going to write. 65.97. And we're finding the area of a sector. Okay? So this is inches squared. Okay? I totally messed this up here. This is not inches squared. This is not inches squared. I'm not finding an area. I'm finding a length of an arc. This is where I'm finding area. I messed that up, okay? Sorry, this is where I'm finding area. This is where I'm finding length of an arc. So for length of an arc, that's just radians times the radius. That's all I gotta do. And the length of an arc, like if I walked 5 feet, I would say I walked 5 feet, not 5 feet squared, okay? Whereas area, that is squared, right? So find the area of this. Okay, I've already found S to be 150 degrees over 360 times pi times the radius squared. Then you go plug that in, you get 11.78 inches squared. Again, this is area. That was not area, it was the length of a length of an arc, excuse me. It was like taking a walk along here. How long is it to walk along here? Oh, it's 7.85 inches. How long is it to walk along here? Oh, it'd be about 22 inches. Okay? All right. So the last one, let's see, I got 120 over 360 times pi times 3 squared, because the radius again of this circle was 3. And you get 9.42 inches squared. Okay. All right. So you've seen quite a few examples here. The homework for this section, on the next page, I would probably, because this is Corona times, maybe just do like every other problem. Don't do every single problem on this page. This should be really easy because it's just looking at the unit circle. It probably wouldn't hurt for you to do all of those, just because it's just simply looking at your unit circle and going back and forth and figuring out that data, just to get some more examples of that. The rest of these, I don't even think you need to do this because these are just pi over 180 and reduce. I mean, as long as you know how to do that. And then down here, remember, you are trying to find two things. You're trying to find the length of the arc and the area of a sector. So this should be like two parts, and I would make sure you do quite a few of these, okay? I will tell you, don't do 41. That's just going to confuse you, okay? But the rest of these, again, the area of the length of the arc, so arc A is just the radians times the radius. So the radius is 4 times 7 pi over 8, and multiply that into your calculator. That's like the first part. The second part is to find the area. And the area, again, is 7 pi over 8. Now look, here's the problem. I said you can look that up on here, but there's nothing that ends in 8. Right? So 7 pi over 8, that's something we have to go 180 over pi. We have to reduce, which is kind of a pain because it's not perfect. It's 157.5 degrees. So I would put 157.5 over 360 times pi times the radius squared and plug that in. So remember, again, you're finding two things here. Okay? Alright, that is that. There's no second page of homework. Okay? Sorry to get this up there in about 16 plus minutes. I wanted to make it shorter, but we had to make sure we got everything in. So the biggest key to this section, this unit circle, ladies and gentlemen, know what it looks like, know how to use it. Work through this homework. Peace out.